Good afternoon. Good afternoon. Good afternoon. Afternoon, everyone. हाँ ये बच्चा बड़ी आ गया. Yes, बच्चा, I am here only. Hello, बच्चा. Good afternoon, Bhavna. Good afternoon, बेटा. हाँ भाई, सब ठीक ठाक. जल्दी जल्दी आ जाओ भाई. Come on, Avengers, assemble. Start करेंगे जल्दी. How are you, बच्चा बड़ी? Welcome to the second session of vector algebra. Fine. Okay, 5n, fine. Very good. I'm fantastic. How are you, sir? I'm fantastic. All good, bachcha badi. Yes, Avengers. You guys are Avengers. You will save the future. You will save the earth. Chalo, jaldi. Good afternoon, Nikhil. Love you 3 million. Love you 3 million. 3000 से नहीं होगा. कहाँ चले? Okay. See, last class, if you remember, if you have followed the last lecture, we have discussed the types of error, correct? The types of error. First one types of vector. First one we discussed zero vector, then we discussed unit vector. And zero vector, I told kids, not that important. This one is most important, correct? That's why we discussed a lot of questions on unit vector. We will discuss it today also. More questions we will discuss today also. If you remember how we defined unit vector, I said you put a cap over it. You put a cap over it and it is defined as complete vector divided by its magnitude. That means, I told you last class, if a vector you writing as ax I cap plus ay j cap plus az k cap. Why I can write any vector like this, I will tell you in the next class. Just remember, any vector we can write something I cap plus something j cap plus something k cap. Then its magnitude we write. Under root ax square plus ay square plus az square. And if you divide these two, you will get unit vector. Means either you can take this as common, you can take this common, you can take this common like 1 by under root ax square plus ay square plus az square, and then write this thing ax I cap plus ay j cap plus az k cap. This is how you write unit vector, correct? This we discussed in the last class. If you want again an example, please first, let's say a vector is written as 3i cap plus 4j cap, quite common because its magnitude we know it comes integer. So how to write a cap? A cap we write First of all, find the magnitude. If you find the magnitude of this vector, it's under root 3 square, which is 9, plus 4 square, which is 16, under root 25, which is 5. Correct? So here what you can write? You can write 1 by 5 common 3i cap plus 4j cap, or you can write 3 by 5 I cap plus 4 by 5 j cap, multiplying 1 by 5 to both terms. Okay? This we have discussed last class. Okay? We will solve more numericals on this, but after these two types of vector, let me tell you more types of vector. Another type of vector is co-initial vector. Co-initial vector. Now, as the name suggests, co-initial means the initial. I told you one vector has 2 points, correct? A vector has 2 points, the head and the tail. This tail is known as initial point. The tail we call initial point, and the head, this head we call terminal point. So co-initial vectors means, co-initial vector means कि initial point is same. Same initial point. Okay? Same initial point. Just remember it. Then we have, this one is important, this one is important. Collinear vector. Collinear vectors. What are collinear vectors, bacha? Anyone can tell me? Collinear vectors, come on, tell me. Anyone, bacha body? Collinear vectors, any idea? Any help from the Google? Come on. On same plane? No. No. On same plane, nahin. Vectors are in the same plane? No. That is known as coplanar vector. Same line, very good. Very good. Same line, very good. Vectors along same line. Vectors along same line. Now, if vector is along same line, please understand, if vector is along same line, let's say this is the line we are talking about. Okay? So any vector along this same line, let's say two vectors, at least two vectors. This is one vector, this is another vector, and let's say this is another vector. Three vectors I am drawing. Let's call it A vector, B vector, C vector. Tell me, are all collinear vectors? Tell me, A, B, C, are all collinear vectors? Parallel to each other, okay, that is the doubt. Are all collinear vectors? The answer is, come on, tell me. A, B, C, all three are collinear vectors, yes or no? No, sir, no, sir, no, sir, no, sir. Okay. No, sir, only one student has told yes, sir. Okay, A and B are collinear, A and B are collinear. Spurti is saying yes. Parallel. Don kahan se aa gaya, bhai? Okay. हाँ भाई देखो, please understand, vectors along same line. I'm not saying कि vectors should be parallel. I'm saying vectors should be along same line. This is a line. Any line can have two directions, this or this. Okay? So that means कि any vector along the same line, that means either parallel or anti-parallel. Means collinear vectors can be either. Collinear vectors can be either parallel vectors or anti-parallel vectors. Collinear vectors, parallel or anti-parallel, both will be known as collinear vectors. It means here A vector, B vector and C vector are collinear vectors. No problem. Out of which A and B are parallel, no doubt. A and B are parallel vectors, while A and C or B and C vector are anti-parallel vectors, but all of them are collinear vectors. ठीक है, please, है ना, these small thing ना we need to clear. Okay, bacha buddy. So collinear vector doesn't only mean parallel vector. Collinear vector can be means anti-parallel vectors can be also known as collinear vectors. ठीक है, so you can say कि collinear vectors can be divided into two parts, parallel and anti-parallel vectors. I hope this point is clear, बच्चा बड़े. अरे हाँ भाई. Okay. चलो, let's see this. Let's say this is A vector. This one is B vector. This one is C vector, and this one is D vector. The digit 4, है ना? Tell me, which set of vectors are collinear vectors? Which set of vectors are collinear vectors? Come on, name them. ACD, ADC, A and D, ADC, ACD, ADC, ADC. Okay, that means most of you have got it. ठीक है, very good, very good. नहीं बेटा, A and D is wrong. A and D is wrong means A and D is not completely true. ठीक है. What I said कि parallel as well as anti-parallel vectors can be known as collinear vectors. So you can see A and D are parallel, but C is this is a straight line. Don't worry about this. Don't say this is a little bit inclined, sir. ठीक है, complete straight line. This is digit 4. So A vector and D vector are parallel. So obviously they are collinear. Also C vector is anti-parallel to A and D. So all three, A vector, D vector and C vector are collinear vectors, where A and D are parallel and AC and DC are anti-parallel, but parallel and anti-parallel both we call collinear vectors. So sir, if two vectors are collinear, how we can identify? Okay, diagram is clear. But if the vectors are given in the form of I cap, J cap and K cap, then how to identify? For that, you have to understand if A vector and B vector are collinear, then B vector should be plus minus lambda times A vector, where lambda is any real number. Lambda is any real number. ठीक है? Sir, but DC vectors are in same line. No problem. Same line, okay, no problem. They must be parallel or anti-parallel. If any of these criteria defined, fulfilled, and a parallel or anti-parallel, we can call it collinear vector. ABC is wrong. Yes, ABC is wrong because B vector was perpendicular. B vector was perpendicular. Okay. So two vectors are collinear, then they should be related like this. Example I can give you. Let's say B vector is 2 times A vector. B vector is minus 3 times A vector. B vector is 1 by 3 times A vector. It can be fraction also. Okay, B vector is minus 2.5 times A vector. Any real number. Fraction also. Not necessarily integer, it should be integer only. Okay? All are the example of collinear vectors. Okay? All are the example of collinear vectors. Now, what happens, bacha buddy, please understand this topic. Multiplication of a vector by a scalar. Multiplication of vector by a scalar. Here a vector is a vector, right? And 2 is a scalar quantity. It is just a number. So it is a scalar quantity, right? So if you multiply a vector with a scalar, then what happens? Then bacha, magnitude will change. Magnitude will change. Obviously, this number should not be plus minus 1. This number should not be 1 plus minus 1. Then magnitude remain same. Okay? But if you multiply with some number which is other than 1, then what will happen? The magnitude will change. Like if you multiply with 2, the magnitude will become double. If you multiply with minus 3, ignore the minus sign. If you multiply with 3, the magnitude will become 3 times. Then what is the use of minus sign, sir? Minus sign means the direction has been reversed. The direction has been reversed. That means if I draw a vector and b vector, please understand. If you say this is a vector, let's draw a vector like this in every case. This is a vector. This is a vector. This is a vector. Okay. In every case, let's say this is the a vector towards right side. Please understand. From basic, I am telling you, bacha badi. I know most of you might be having the idea, but please have patience. Okay? Let's say in all 4 example, a vector is towards right side. And the same magnitude. Now, if I want to draw b vector in the first case, then please understand. B vector is 2 times a vector, means the magnitude of b vector is double of magnitude of a vector. Okay? And if it is a positive number, then it is going to be parallel. If it's a positive number, the direction will remain same. And if it is a negative number, then direction will be reversed, means the parallel, it will become anti-parallel vector. Means here b vector and a vector. Come on, tell me first case, b vector, a vector, parallel or anti-parallel? Come on, tell me first. Tell me the second, third and fourth. Come on. You can write PA, P8, something like this. All 4 cases. Tell me all 4 cases. First case parallel, I got it. First case parallel. Second case anti-parallel. Very good. Second case anti-parallel. Because this is a negative. Third case. Come on, third case. It's 1 by 3. Yes, it's Papa. Correct. Parallel, anti-parallel, parallel, anti-parallel. Okay? Because here numbers are positive, so parallel. Here numbers are negative, so anti-parallel. Okay? So that means if I want to draw b vector, I will draw here b vector. Let's draw with some other color, white color. So here I will draw b vector something like this. I will assume this length is double of a vector. Here I will draw it anti-parallel. The first one parallel, the second one anti-parallel. Here I will draw parallel, but I will keep the magnitude less. And here I will draw like this, anti-parallel, but magnitude more. Please understand. B vector, since magnitude is double, so this length is double of a vector length. Second case, due to minus sign, it is anti-parallel. And I'm just assuming that this length is triple of this length. Then here B vector is parallel, but the length will be 1 by 3rd of this length. The length of B vector arrow is 1 by 3rd of the length of A vector arrow. I think it is clear, right? Similarly, here also it will be anti-parallel due to the negative sign. And the length we are assuming 2.5 times of A vector. I rest my case here. I hope this is clear, bacha buddy. I bol there. So please understand what happens when you multiply a vector with a scalar. And now what happens if you multiply vector with a scalar? Its magnitude changes. Its magnitude may change. Its magnitude may change. Direction, same or opposite. So when you multiply a vector with a scalar, the magnitude may change. Why I'm using may word? Because if you multiply with -1, then magnitude remains same. Means if you write b vector equal to minus a vector, minus a vector means it is -1 multiplied. So magnitude will remain same, but the direction will be changed. It will be opposite. ठीक है भाई? That's why I'm writing magnitude may change and direction. Either it will remain same or it will become opposite depending on the sign. Plus sign you are multiplying or negative number you are multiplying. Sorry. ठीक है बच्चा? That means कि if I write a vector equal to 5i cap minus 2j cap minus 3k cap, can you tell me what will be 2 times a vector? Come on, tell me what is 2 times a vector. I know these are basic things, but after covering the basic only, I can go up to some tough numerical. Don't worry, I will give you the tough numerical also. Yes, multiply 2 to the every term. So here multiply 2, 10i cap, multiply 2, minus 4j cap, multiply 2, minus 6k cap. So 2a vector will be some simple maths. Okay? No doubt? Okay, if no doubt, then let's move ahead. Let's see one question. A vector is, let's say 4i minus 7j plus 9k. B vector is I plus 2j minus 3k. I want you to find A vector plus 2b vector. I want you to find A vector plus 2b vector. Okay, we are getting some answers. Good. But answers are different, little bit different. Okay, we will check. The majority are getting 6 minus 3 plus 3. Okay. Come on. Very good. Please participate. भाई कॉपी पेन साथ में रखने का है ना? वेरी गुड. हाँ भाई, क्या करने का भाई इसमें? What we have to do here? First, make it 2b vector. If you make it 2b vector, so multiply 2 to every term. It will become 2i cap. This 2 will become 4. And this minus 3 will become 6. Minus 6. Now you add. If you add, it will become 4 plus 2. I with I. Minus 7 plus 4. And 9 minus 6. This is our A vector plus 2b vector. ठीक है. Now the real question I wanted to ask. Find unit vector along A vector plus 2B vector. Find unit vector along A vector plus 2B vector. Will the COVID extended and lockdown? No, we are not going to witness any lockdown. Because now we are immune. How are you? Any more questions like this? Sir, we want Thanos question, not Loki question. Yes, you will get the Thanos question. Don't worry. But preparation is going on, yaar. Have you ever seen a 6 months old kid or 9 months old kid start running like this? Chalo, bhai, chalo. Understand? See, the tough question was this one only. But to approach this question, first I told you, please understand my teaching process, what I'm trying to do. First of all, I told you multiply 2, how to multiply any vector with a number. Then I told you how to multiply and add. Now I'm telling you how to take the unit vector. Please understand the process. Chalo bhai. So simple unit vector, let's write it with eta cap. Any number you can give. Any symbol you can give. So first of all, we have to find A vector plus 2B vector, which we have already found. Now you know what to do. This is the vector. You have to find unit vector along this vector. First of all, find the magnitude of this. So what you can do, I can say it's 1 by under root 6 square, 36 minus 3 square is 9 plus 9. And here you can write okay. If you add it, I think it is coming 54. 54. So you can write unit vector is 1 by root 54. You can take common. And 6i cap minus 3j cap plus 3k cap. Okay? Now I think you are ready. Now I will give you the question directly. Okay? I hope you have noted. Most of you have already solved. Very good, bacha body. Chalo. Let's see. Next question. A vector is 13i cap minus 8j cap. B vector is minus 2i cap plus 4j cap plus 3k cap. The question is find unit vector along 2a vector plus 5b vector. Find unit vector along 2a vector plus 5b vector. Come on. Okay, one answer we are getting. I want unit vector. I want unit vector. Come on, come on, come on. ठीक है, take your time, no problem, take your time. Give me correct answer. हाँ भाई, कहाँ गया थैनोस क्वेश्चन? Okay, different answers. Siri, beta, you divide with the magnitude also. I'm asking you unit vector. I'm not asking 2a vector plus 5b vector. Okay, more or less. चलो 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 चलो, कोई नहीं कोई नहीं. Okay, so first we will write 2a vector, which is multiply 2 here. 13 into 2, 26. I cap minus 8 into 2, 16. J cap. 5b vector is minus 2 into 5, minus 10. 4 into 5 plus 20, and 3 into 5 plus 15 k cap. Now add. If you add, you will get 16i minus 4j plus 15 k cap. But this is not the final answer. This is just 2a vector plus 5b vector. So we have to find the magnitude of this. Okay, this is 2a vector plus 5b vector. Now we are supposed to find 2a vector plus 5b vector magnitude, which is under root 16 square, which is 256, plus minus 4 whole square will be 16, plus 15 square is 225. 200, 200, 400, 400, 25, 41, 41, and 56 is 97. Under root 497. You can take your time, you can do the calculation, you will get under root 497, and in the comment box also I'm getting the same thing. Plus 4, have I done any mistake? Yes, this is mistake, plus 4, but that doesn't change our this magnitude. Thank you for correcting. Any other mistake? Chalo, nahi hai. Okay, fine. Then what is unit vector? You can write like this, any symbol. So we will divide this and this. What you can say 1 by under root 497, है ना? 16 I cap plus 4 J cap plus 15 K cap. This is our final answer. Most of you got it correct. You can pat your back. Congratulations, bacha. Because this is not an easy question, I'm telling you. Chala. Chale, aage chale. Last thing before going towards addition of vector. Okay? Last thing. Bacha buddy. If I say there is one vector, a vector whose x component ax, y component ay, z component az, b vector whose x component is bx, y component is by, z component is bz. Now if I am saying a vector and b vector are collinear, means either parallel or anti-parallel, then you know कि b vector should be some multiple of a vector. Let's say b vector is 2 times a vector, Please understand. Let's say B vector is 2 times A vector. It means what? It means if you multiply 2 to the A vector, you will get B vector. So if you multiply 2 to the A vector, it will become 2AX. Means BX will be 2 times AX. BY will be 2 times AY. BZ will be 2 times AZ. It means the ratio of respective I cap component, J cap component, and K cap component will be same. I hope you understand this point. So then AX by BX है ना equal to AY by BY equal to AZ by BZ. Let that sink in. Please understand. Take your time. What type of question can I ask you based on this concept? Very good. One answer is already there. Balaji is there. MSR is there. Dikshit. Naruto. Okay. Everyone is getting the correct answer. Everyone is getting the correct answer. And that answer is 9. I hope it makes sense. You have got this. If the vectors are collinear, then same number will be multiplied to each term to get the another vector. That means if you take the ratio, the ratio should be constant. If the ratio is positive, like here, what you can do, you can take any two ratio. Like 2 by 6. It should be equal to 3 by y, and it should be equal to minus 4 by minus 12. You can check. It's 1 by 3. You don't need to equate all three. Any two will work. Either you can equate these two or these two. Okay? So 1 by 3 equal to 3 by y. Leave this. So y equal to 9. Tell me, A vector and B vector are parallel or anti-parallel? They are collinear, okay. But collinear, I told you, it can be parallel or anti-parallel. Tell me, A vector and B vector are parallel or anti-parallel? Come on. Parallel. Why not anti-parallel? Come on. Same sign. Okay, same sign. So it will be always same sign. Because the ratio is positive. The ratio, if you take, it's 1 by 3. 1 by 3 is positive. It's not coming minus 1 by 3. It is coming 1 by 3. So it is positive. So ratio is positive. Then we are going to say it is parallel. Ratios are equal, okay. But that equal value is positive. 1 by 3 in all cases. Okay. Tell me one more thing. If A vector is 4i plus 8j plus 6k, B vector is 2i minus 2i minus 4j. Tell me, A vector and B vector are parallel or anti-parallel? A vector and B vector are parallel or anti-parallel? Okay, so answers are going anti-parallel, anti-parallel, anti-parallel. Parallel. Okay, one answer suddenly comes parallel. Why it is anti-parallel? Because sir, here if you take the ratio of 4 by minus 2, 4 by, sir, 4 by minus 2, 4 by minus 2, here ratio 8 by minus 4, here ratio 6 by 3. So this is minus 2, this is minus 2, this is plus 2. So these two are equal, these two ratio equal, but last one is not equal here. So the answer is, the question is wrong, sir. It's neither parallel, not nor anti-parallel, nothing. For anti-parallel, all three ratios should be negative. And same, but negative. But suddenly you can see here it is positive. So A vector and B vector are not parallel. Also, they are not anti-parallel. You have been trapped. चलो भाई, ट्रैपिंग हो गया, आगे चले. But I hope you understood this thing. है ना, इमोशनल डैमेज हो गया. Yes. Yeah, because where you will be trapped now, you will remember it for long, right? Like I always say this example: if you are taking a turn, right, and you are on a bike, full speed, let's say 100, and then you bend the bike, but after that there was a breaker or some pothole, and what you did, you slipped after that. Okay? Now you have been trapped, right? You made an accident, but the next time when you will taking the same turn, then you will remember, no. And this time I don't have to go at that speed. This time I have to take care of that breaker or pothole, whatever it was. Okay? And that's what we call learning from the mistake. And that's what we call, now you are an experienced person. So experience means learning from your mistake. If you are not learning, again going with 100 km/h, again falling, again doing the same thing, that means you are not getting any experience. Chale aage bhai. Now come to the most important topic, which is addition of vectors. Before that, tell me, what are equal vectors? What are equal vectors? What are equal vectors? Obviously, same magnitude, same direction. Same magnitude, same direction. Equal vector means same magnitude, same direction. That means two vectors you will call equal only when their orientation will be same, as well as the length of the arrow is also same. Okay? Then only you can claim that A vector is equal to B vector. Only magnitude same, you can't claim it is a, like, if I say A vector is 3i cap plus 4j cap and B vector is 4i cap plus 3j cap, can we claim that A vector is equal to B vector? No. But can we claim that magnitude of A vector is equal to magnitude of B vector? Come on. Can we claim that magnitude of A vector is equal to magnitude of B vector? This statement is correct or wrong? Correct or incorrect? This statement which I have written here. Magnitude of A vector is equal to magnitude of B vector. Yes, and both is equal to 5. If you do the calculation, So this is correct. But can I claim A vector equal to B vector? Can we claim A vector equal to B vector? No. Just because the magnitude is same, you can't claim the vectors are also equal. No. Because the directions are different. Because the directions are different. I hope it is clear. Simple topic, equal vectors. It means what, bacha? It means, can I say कि any free vector, or you can remove the free word also, can be displaced parallel to itself. Any free vector can be displaced parallel to itself without changing its magnitude. Yes, because please understand, if you displace this vector parallel to itself anywhere here, and you call it, let's say, another vector C vector, but since the orientation is same and the length is also, means magnitude and direction both are same, so you can say that C vector is equal to A vector. That means any vector we can displace parallel to itself without changing its magnitude, means you should not change the length of this vector. Okay? Such vectors we call free vector. But at our level, this is applicable to all kind of vectors. Okay? Just don't worry about the word, sir, what is free vector? Forget about the word free. Any vector we can do like this. Chalo bhai. Another little thoda sa. What do we mean by angle between two vectors? Angle between two vectors. So simple, sir. Angle between two vectors, angle between two lines, it's just simple. No. There's a theory. First of all, you have to join the vectors head to head or tail to tail, fashion, orientation, whatever you can say. First of all, you have to join the vectors in head to head or tail to tail orientation. Then, smaller angle between them is known as angle between vectors. The smaller angle between them is known as angle between vectors. Okay. Let's say that this is one vector, this is another vector. Okay. I want to know what is angle between these two vectors. What is angle between these two vectors? One vector is this side, another vector is this side. Okay. So what we have to do? You can displace any one of them, as I told last slide. You can slide any vector, you can displace any vector. So if you are displacing it parallel to itself, you make it like this, tail to tail joint. Don't place it here. Don't place it here. Okay? You have to place either tail to tail like this. You can place it like this, tail to tail. Then once you place it tail to tail, then you have two angles. The smaller angle here, let's say theta, and this angle, which is 360 minus theta. Which angle we should consider? The smaller angle. So this theta will be known as angle between vectors. This theta, the smaller angle, will be known as angle between vectors. Now, what if the situation is like this? Let's say if I say, bacha party, कि this is A vector, this is B vector, and this angle is given 60 degree. What is the angle between vectors? What is the angle between these two vectors? Shall I call this angle? Shall I call this angle 120 degree is the answer, sir? Angle between two lines. Angle between two lines, sir, 120 degree. Shall we call 120 degree? Or shall we call 60 degree as the answer? So first of all, if you say, sir, this 120 degrees, sir, two lines are there, na? Two lines like this. So angle between them is 120. Angle between them is 120, then it will be wrong. It will be wrong. Or to avoid the confusion, let's remove this thing. Hai? Two vectors are there like this, sir. Hai? Angle between them is 120. What is the problem? Yes, there is a problem. Because the vectors are head and tail joint. The vectors are head and tail joint. So what you can do, either you can displace this here and make it head to head. You can make it head to head. So this angle we shall consider angle between vector, which is 60 degree. You can do like this, or understand here. This one was the vector, correct? So either you can displace this vector backward to make it head to head joint, or what you can do better, you can displace it like this, and then you can call it this angle as angle between vector. Either make it tail to tail joint, or you can make it head to head joint. Okay, and the smaller angle we will call angle between vector. So 60 degree is the answer, not 120 degree, not 120 degree. Okay. Similarly, let's say this is 80 degree. This is 80 degree. What is the angle between vectors? What is angle between vectors? Should I call 80 only? No. Yes, very good, very good, very good. 100, 100, 100, yes. Because if you call it 80, then it is head to tail joint. This is wrong. It should not be head to tail joint. So what we can do, either we can displace this vector, this horizontal vector, in the right side. And then you should focus on this diagram, this vector and this vector. This is A vector, this is B vector. Okay? So now this is tail to tail. So focus here, focus here. So this is 100 degree. This is 100 degree. So that means one thing, angle between a vector can lie only between 0 degree to, remember this, angle between two vectors will be either acute or obtuse. Either it will be in first quadrant or it will be in second quadrant. Quadrant I'm telling because now we will see sine theta and cos theta. So you better know कि sine theta is positive in which quadrant, negative in which quadrant, same for cos theta also. ठीक है? Okay, बच्चा buddy, last. If I say this is an equilateral triangle, this is A vector, this is B vector, This one is C vector equilateral triangle. I hope you know all angles are 60 degree, inside angle are 60 degree. So question is, find angle between, question number 1, A vector and C vector. Question number 2, B vector and C vector. Question number 3, A vector and B vector. Come on, tell me the answers first. Nice. And they is saying 60, 60, 120. Balaji is saying 60, 60, 60. Pananjali is saying 60, 60, 120. Brutal death. Bhai sahab, 160. Okay, 60, 60, 120. Pujita is saying 60, 60, 60. Dikshit, 60, 60, 120. Okay, so I will also go with the majority. 60, 60 and 120. I also feel it is correct. Okay? Check the first one. Angle between A vector and C vector. Angle between A vector and C vector. So if you look at A vector and C vector, these are tail to tail joint here. Please understand, these two are tail to tail joint. So I will take this angle 60 degree as the angle between A vector and C vector. I'm repeating. Why? Because A vector and C vector are tail to tail joint. So no need to drag any vector, shift any vector. Between B and C, between B and C, if you look here, so B and C, B vector and C vector are head-to-head joint. So nothing we have to do. It is also 60 degrees. So this answer is 60 degree. This answer is also 60 degree. What about between A vector and B vector? This angle is 60 degree. But wait a minute. A vector head is lying over B vector tail. A vector head and B vector tail are at one place. So this 60 degrees should not be the answer. Then what we can do, either you can directly do 180 minus 60 directly, or to visualize, what you can do, you can shift this A vector in right side. You can imagine we have shifted this A vector right side. So this angle will become angle between A vector and B vector, which is 120 degree. ठीक है, समझ में आया क्या? चलो, addition of vectors. Addition of vectors. Vector law of addition. There are 3 laws of addition. The first one is triangle law of addition. Second one, parallelogram law of addition. And the third one, polygon law of vector addition. If you understand triangle law, polygon law is just an extended version of triangle law. And these two are more or less similar, you will realize. Okay? So let's start with triangle law of vector addition. Dekh bhai, let's say there are 2 vectors, anywhere in the plane, you don't worry. This is A vector, this one is B vector. Okay? A vector and B vector, are we ready? Chale, triangle law start kare. Any problem? Any doubt till now? If any doubt, please you can ask me. We can take a breather of 2 to 5 minutes. Tell me if it is going too fast for you. Or is it too fast? Too slow? चले स्टार्ट करें. Too slow? ओके मीडियम, ठीक है चल। हाँ भाई, ट्राइंगल लॉ, ए वेक्टर देयर, बी वेक्टर इज देयर, वी वांट टू ऐड दीज टू वेक्टर्स, है ना, वी वांट टू ऐड दीज टू वेक्टर्स। सो व्हाट डज ट्राइंगल लॉ से कि जैसे कि join head of one vector with the tail of another. Join head of one vector with tail of another. ठीक है, simple thing. Join head of one vector with tail of another. So you can shift any one of them. Let's shift B vector only. Anna, let's shift B vector only like this. Okay, you can see we have joined the head of A vector. We have joined the head of A vector with the tail of B vector, with the tail of B vector. Tell me, what will be angle between vector? Do you think the angle between vector will be this theta? No. Because head to tail joint, so angle between vector will be this theta. Okay? But we will do the derivation in parallelogram law. Here just understand how to identify the resultant. Okay, so once you have joined the head of one vector with the tail of another vector, then you can see the tail of A vector and B and head of B vector are not engaged. They are free. So what you have to do, you have to join the free ends. The tail of A vector is free, it is not engaged. The head of B vector is free, it is not engaged. Join the free ends. Join the free ends. Like this. Now, if I join the free end, sir, I should put the head here or here. That is the doubt. I should put head here or here. So the simple rule you have to remember, join free ends in head to head and tail to tail fashion to get a resultant vector. To get a resultant vector. That means okay, Susmita, we will talk about that. Okay, so this is A vector, this is B vector. Now we have to join the free end. How we have to join the free end? Should I put head here or here? Tell me where I should put the head, at B vector or A vector? Tell me where I should put the head, at B vector or A vector? At B vector. Why? Because we have to join. We have to join like this, head to head. So here is the head. So I will put a head over here. So automatically it will become tail to tail and head to head. So this is our resultant vector. This is our resultant vector, which is nothing but A vector plus B vector. Nothing but A vector plus B vector. Okay? That means in a vector triangle, how do you identify that this one is resultant vector? So understand, if you look at A vector is tail to tail, but here it is head to tail. B vector here head to head, but here it is head to tail. Only one vector is tail to tail and head to head joined. So how to identify a resultant vector in a vector triangle? What we call it? What this triangle we call it? We call it vector triangle. In this triangle, one is resultant vector. How to identify the resultant vector? Only one vector will be there in a vector triangle, which will be head to head and tail to tail joined. That vector will be our resultant vector. The one which is head to head and tail to tail joined. Like where we have done this. Chalo. See here. ABC. Tell me what should be the relation between A vector, B vector, and C vector? Tell me. Or which one is the resultant vector? Which one is resultant vector? Which one is resultant vector, bacha? The one which is head to head and tail to tail joined, the one which is head to head and tail to tail joined. If you look at A, A is here tail to tail, okay. But see the other end also. A vector head is joined with B vector tail. No, that means A is not a resultant. है ना? B vector the same problem here. B vector tail is joined with A vector head. So A vector and B vector are not resultant. Who is resultant? C vector, because the head of C vector, it is with head of B vector. Tail of C vector is joined with tail of A vector, so C vector is resultant. So I should write here C vector is resultant of A vector and B vector. So the relation here will be C vector is equal to A vector plus B vector. Don't write C equal to A plus B. Don't write C equal to A plus B. The magnitudes are not like this. Magnitude are not like this. Vector, C vector is resultant of A vector plus B vector. We are not adding the magnitude. We are adding the vectors. Please understand this basic thing. Okay, so this is how you relate the vectors in a vector triangle. Okay, bacha buddy? Come to the second law. Which is parallelogram law. ठीक है भाई, इसका क्या रूल है? What is the rule of parallelogram law? Let's draw the vectors like this only, है ना? Like in the previous case, this one is A vector, this one is B vector. So join the vectors tail to tail. You can join head to head also, but it's better you join tail to tail. Join the vectors tail to tail. Okay, do it. Bring this B vector not here. Should I bring the B vector here, bacha? No, because if you bring the B vector here, then it will be head to tail. Bring the B vector here. Bring the B vector here so that tails are joined together. The tails are joined together. Now, after this, what we have to do? Construct a parallelogram taking the vectors, these vectors, as its sides. Means you consider that these vectors are the sides of a parallelogram and then draw the complete parallelogram. So if this is a parallelogram, sides of a parallelogram, so what we should do? I think we should, how to draw complete? So what I will do, I will construct a parallelogram like this. Can I do like this? Okay? Construct a parallelogram taking these vectors at its sides. Yes, definitely we can do like this. Okay? So we have made so understand, if you look at this vector, equal in magnitude and parallel, so we have full right to call it A vector and we have full right to call it B vector because they are equal vectors. These two vectors are equal, these two vectors are equal. Now, then sir, who is resultant here? The diagonal emerging from common tail is the resultant vector. The diagonal emerging from common tail. See, there are two diagonals, bacha buddy. One is this one. Another one is this one. So I'm not saying longer diagonal or shorter diagonal. Please understand. I'm not saying longer or shorter diagonal. What I'm saying, you have joined A vector and B vector tail to tail. Correct? Correct. Then the diagonal which is emerging from this common tail, which you had joined earlier, from there the diagonal which is emerging, that will be known as the resultant vector. So this white line we will call the resultant vector. R vector equal to A vector plus B vector. But it is not tail to tail. See, triangle rule is over. Whatever we discussed, this tail to tail, head to head, that was in triangle rule. Now, parallelogram rule, what is the rule? You have to join the vectors tail to tail, A vector and B vector, which you are adding, join them tail to tail, then construct a parallelogram like this. After that, one of the diagonal will be known as resultant. Which diagonal? The one which is emerging from this common tail. Simple thing. Now forget about whatever we have discussed in triangle law. sir, is it clear, bacha? Okay. Now, if you look closely, why I said ki parallelogram law and triangle law are same, because if you look at this portion, come on, see here. If you take out this portion and look here, bhai dikha? Can you figure it out? The triangle law is hidden inside this parallelogram law. That's why I said that both are similar. That's why I will do the derivation only in one part. Okay? If you see this lower triangle or the upper triangle, anyone, lower or upper triangle, you will clearly see that A vector, B vector, head to tail. Understand? A vector, this is B, so this is also B. B vector, head to tail, and the resultant is head to head and tail to tail. Come on. This was the triangle rule, triangle law, right? So both are similar. Okay? Then what is the magnitude, sir? Okay, what is the magnitude? So magnitude will be equal to, if you say the length of this arrow is small a, means magnitude of A vector is small a, magnitude of B vector is small b, then what is the magnitude of this R vector? What is magnitude of this R vector? So either you can do the derivation, I think derivation we had done in Mopser. Mopser had told you the derivation, if you remember. Okay? If this angle is theta, theta is the angle between A vector and B vector. Why can I say that theta is the angle between A vector and B vector? Can you tell me again? Why we can say that theta is the angle between A vector and B vector? Come on. Because they are, come on, Majabadi. Why we can claim theta is the angle between A vector and B vector? Because they are tail to tail joined. Very good. We can claim this angle as angle between vector because A vector and B vector here are tail to tail joined. Very good. Okay? So you should know three things: the magnitude of A, the magnitude of B, and the angle between vectors. You should know two things: magnitude of A, magnitude of B, and angle between them. Then the resultant lies somewhere. Between them. And if you want to know exactly where, so I have told you along the diagonal of the parallelogram. So most of the time we draw this diagram. Only the half diagram we draw. Because the full diagram you have to construct complete parallelogram. Okay? So generally we draw like this: A vector, B vector. The resultant of A vector and B vector will be somewhere in between, because the diagonal will be always somewhere in between A vector and B vector. What is the value of this resultant? So the value of this resultant, the magnitude of this resultant is under root a square plus b square plus 2ab cos theta. I hope you are familiar with this term. Under root a square plus b square plus 2ab cos theta. If you know the derivation, it's good. If you don't know, it doesn't matter. Okay? You are never going to do the derivation, although it has been already told. Okay? So resultant magnitude is under root a square plus b square plus 2ab cos theta. Tell me, the resultant vector of a vector and b vector, the resultant of a vector and b vector, it will be a vector quantity na yaar. The r is a vector quantity na. So if r is a vector quantity, so this is what? This is only the magnitude of r vector. So what we should find? Another thing. So another thing we should find the direction of r vector. Only we have written magnitude of r vector. We have to find direction of r vector. How to find direction of r vector? How to find direction of r vector? So we will find the angle made by the resultant with one of the vector. To find the direction of r vector, listen to me. To find the direction of r vector, you can find the angle between r vector and either a vector or b vector. Angle between r vector, listen to me very carefully. I'm repeating it again and again because this is where you do the mistake. If you want to find direction of r vector, you have to find the angle between r vector and one of the vector. Either a vector means r vector, a vector, this angle you can call alpha. You can find this angle. Or you can find this angle between r vector and b vector. In this diagram, either you can find this angle between r vector and b vector, or you can find the angle between r vector and a vector. Either you can say alpha or beta. Anyone, not both. You don't need to find both alpha and beta. Either alpha or beta. Okay? Now, obviously, we have formula for that also, beta. If you are finding alpha, the formula of tan alpha is, please remember the format. Formula of tan alpha is something into sine theta divided by something into cos theta. See, I can do the derivation, but the thing is you will forget. That's why I'm saying remember the formula. I'm trying to tell how to remember this formula, or at least how I remember, because I do not derive it again and again. Okay? Something, you have to remember the format. Something into sine theta divided by something plus something into cos theta. Now, what will be here something, sir? So either A or B. First of all, remember the format. Something sine theta divided by something alone here plus something into cos theta. Either A or B. Now, whatever you multiply to sine theta, the same thing you will multiply to cos theta. Whatever you multiply to sine theta, the same thing you will multiply to cos theta. And the another one will be here alone. So who will be alone? That vector magnitude with which you are finding the angle. Again, alpha is the angle between r vector and a vector. Alpha is the angle between r vector and a vector. So that's why, my friend, A will be here alone. Who will be alone? That vector magnitude with which the angle is being found. Who will be alone? That vector magnitude with which angle we are finding. Okay, so we are finding tan alpha. Alpha is the angle between r vector and a vector. A will be alone, so here will be B and B. So the answer is B sine theta upon A plus B cos theta. Similarly, now I request, can you, using same logic, can you tell me what is tan beta? It will be very easy to remember. Come on. Very good. Come on, come on, come on. Last 5 minutes बच्चा बोल दे. Very good, very good. Nice. That means you are with me till the last of the lecture. Very good. Correct, Bhavna. Correct, Pananjali. Srisha, yes, it is correct, beta. MSR, correct. Chalo, chalo. So what I said, something into sine theta divided by something plus something into cos theta, correct? So here alone will be B. Alone will be B because we are tan beta. Beta is the angle between R vector and B vector. B will be alone and here it will be A and A. Okay? I hope you understand this. Now we will discuss the special cases of this. When the angle between vector will be 90 degree, 0 degree, 180 degree, but with a fresh mind because those cases are important. Those cases are important. So with a fresh mind, we will study in the next lecture. So we will keep till here the resultant formula. I will write this formula again. I will make you understand, make you remember this formula again. I will tell you the trick again in the next lecture. But last 5 minutes we have. So I want you to solve some very easy questions. Let's revise last lecture also. This lecture also. Maths NCERT. Reference. Maths NCERT bacha. Not going here and there. Simple Maths NCERT. You are bio student, you might not be knowing this. Okay? Simple question. NCERT based. Standard question. Tell me, easy, tough, I don't know. Solve. Last 5 minutes, we can solve 5-6 questions easily. Example, I will give in the next class, beta. With fresh mind, we will discuss the example. A lot of numericals are there. In this PDF, only a lot of numericals are there. I will give you my numerical also. As you guys said, the Loki problem, EG also, Thanos problem also, I will give you. Chalo, the first question, find values of x, y, and z so that the vectors A vector and B vector are equal. Very easy question. Come on, we should not waste our time here. बोल दे भाई. हाँ. Okay, 2, 2, 2. 2, 2, 1. So many 2. 2, 2, 2, 2, 2, 1, 2, 2, 2. Okay. देखो भाई. A vector and B vector are equal. Only possible when all the components will be equal. Ax equal to bx, ay equal to by. It means here I component which is x, here I component which is 2. So simple x equal to 2. They are not asking collinear or something. In case of collinear, we take the ratio. Here if you take the ratio, it should be 1. Or simply the components should be equal. Here it is 2, here it is y. So y should be also equal to 2. And here it is z, here it is nothing means 1. So z should be equal to 1. Simple. The 2, 2, 1 is correct. 2, 2, 1 is correct. Moving to the next question, which I have also asked you, bacha. A vector given, B vector given. Is mod A equal to mod B? Come on, tell me the first. Mod A equal to mod B. This one answer, tell me first. This one, yes or no? Yes or no? The first one, yes or no? Yes, 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 yes. Because understand beta, mod na, mod. When you apply this mod, it means they are talking about magnitude. They're talking about magnitude. What is the mod of a vector? So it's under root 1 plus 2 square, which is 5. What is mod of b vector? It's under root 4 plus 1, which is under root 5. So yes, both magnitude wise equal. But this part, are the vectors equal? Are the vectors equal? Come on. No, vectors are not equal because the directions are different. Because the directions are different. Simple question. I can say a kind of revision question. We have already done this last class also, today's class also. Just revision ki haan bhai, whatever we have studied, we remember it. Come on, come on, come on, come on. Last 2 minutes, come on. Find the magnitude, find the magnitude. Under root 2 square is 4, 9, 1, root 14. So unit vector will be, either you can take 1 by root 14 common, and you can write 2i cap plus 3j cap plus k cap. Or you can multiply 1 by root 14 to every term. Very good. Very good. Nice. That means lot of students are here with me till the last. Okay, up to good question. Very good. This is the last question we will discuss. I promise. है कोई बाहुबली बनाएगा इसको? No, not correct. Dikshit 7 by root 5 minus 14 by root 5. Yes, that one is correct. One answer we have got correct. Very good, Dikshit. One answer is correct. See, understand. I want a vector. Find a vector in the direction of this vector. So direction will be same. So what you do, you find unit vector in this direction. Find a cap. If you find a cap, but a cap will have a magnitude of only 1, correct? Because unit vector means magnitude is 1. So I think a cap is very easy to find. I cap minus 2j cap. Whole divided by its magnitude. Magnitude is under root 1 plus 4. So it will become 1 by root 5. 1 by root 5 into I cap minus, this is unit vector. And if you calculate the magnitude, you don't need to calculate the magnitude, because the magnitude of unit vector is 1. That's why the name is unit. Unit means 1. Okay. But if you say this is the answer, then it is wrong, because its magnitude is only 1. I want a vector in the same direction. But I want a vector whose magnitude is 7. So let's call it B vector. So B vector, I want magnitude 7, but the direction same as A cap. Please understand. I want a vector in the same direction of A cap, but A cap has magnitude 1. I want the magnitude 7, so I will multiply with 7. So answer will be just multiply 7 there, better. 7 by root 5 into I cap minus 2j cap. You can write like this: 7 by root 5 I cap minus 14 by root 5 j cap. This is our correct answer. So in such question, when they ask you a question like this, so find the unit vector and then multiply with whatever magnitude they demand. Like if they say ki, in the same direction but has magnitude 8 unit, up to this part, the solution will be same. Here I will multiply 8. Okay? Very good, Sandeep. Very good. I didn't see the answer. Okay. Chalo. So I will keep the discussion till here. I hope you have learned something. Next class is going to be a full of numerical class. Because major theory we have done, full of numerical class. Also we will try to cover components of vector. So next class, I think it is going to be interesting. Okay, bacha buddy. That's my time. See you tomorrow. Chale. Tada. Bye-bye. Relax for some time, then get ready for the next class. Chalo. Bye, bacha. Bye, beta. Bye. Nearest railway station? Vijayawada. Tomorrow there will be class. Sunday, Monday, it doesn't matter. I think tomorrow there will be class. You will be notified. Bye, beta.